Guys, so today we solve 18 and 19 and the GRE Math 9367 form. So 18 tell you that the f of x is this one. So basically you can write down this. This is geometric series. So 1 minus x squared plus x to the 4 minus x to the 6. This is 1 over 1 plus x squared. Right. And when you do a differentiation in respect to x, you get 1 minus x squared. And then there's a minus sign here. And the derivative, the chain rule, so 2x. So the answer is D. The answer should be D. Right. So it's simple. Okay, 19. So 19 is ordinary differential equation. Basically, you compute the y triple prime minus 3y double prime 3y minus 1 equals 0. The standard technique is let y to be exponential lambda x, and the plug in, you get lambda 3 lambda squared plus 3 lambda minus 1. This tells you that the lambda minus 1 square cube is 0. So lambda is 1. So let me remind you guys that suppose you get a multiple roots, then each time you have a multiple roots in the ordinary differential equation, you need to add another x. Is x or t? Oh, it's t. It's t. Yeah, so I should use t. Sorry about that. So the answer is exponential t. This is one basis. And another basis is t times exponential t, and the t squared exponential t, and the t cube no t cube. So this is the second basis, third basis. So the answer is A, B, C, some constant. So the answer is A. The answer is A. So this is just asking about the common sense of the ordinary differential equation. So another example is suppose you get lambda equals to 2 or 3, then the answer is exponential 2t, exponential 3t, and some constant. And if you get lambda equal 2 and 2, you have 2 lambda equal 2, then the answer is just exponential 2t plus t exponential 2t, some constant. So this is the common ordinary differential equation. Okay, so number 20. I think number 20 is still easy. So let me try to solve it. So number 20 says that there's a volume which is bounded above by the graph. So there's a graph called 6 minus x squared minus 2y squared. So this is a graph. This is a z, and bounded below by another surface minus. Minus should be here, right? So this is the volume we need to solve. So the calculus tells us that this is the volume, right? And the z is bounded by this one, and that this is lower bound. And for x and y, right? The condition for x and y is that the integral for x and y is x squared is solving this area condition. So the underlying area for this x and y is x squared plus 2y squared. You just change this into this way, and equals to 4, smaller than 4. Right, so this is the integrand. But the problem is there's no such term, no such exactly term as we wrote. So we need to change it into the what we have. Okay, so we can first integrate out z. So basically this is just z. It's just z and 6 minus x squared minus 2y squared and minus 2 plus x squared plus 2y squared. So this is just 8 minus 2x squared, 2 is 5 minus 4y squared, and the dx dy. And we need to write down. So this is the x is this is let me see. Right, so this is x squared plus 2y squared equal to 4, and this is the area we need to solve. So this can be solved for the x in terms of x, right? You have two curves. One is 4 minus x squared square root divided by 2, and another is minus 1/2 4 minus square divided by 2. So this area, this dx dy area, basically is integrated as this one, right? So this is for dy, and for dx, we just from 2 to negative 2 to 2, so negative 2 to 2. So plug this integrand into this. Okay, so we can see which one is the correct answer. It's obvious that correct answer is B. The correct answer is B, right? B is exactly the same as. So in B, these terms matches, and this y is these two, and x is just negative 2 to 2. So this problem does not ask you about to do the integration, but it just asks you about which one is correct. So it's very easy that once you understand the question, then you can easily get an answer, right? So the answer is B. The answer is B.